Hello viewers, in today's class we are going to discuss one important and conceptual problem from definite integrals, right? And the special uh, characteristic of this problem is that here we have to evaluate this definite integral in which both the greatest integer function and signum function are involved, right? So what we will do in this problem, we have to make use of the definition of greatest integer function and signum function to solve this integral, right? So let us start, and let us first call this integral as I, right? So now here we see that we have the integral from -1 to 1 e raised to greatest integer of x over 2, and here we have the signum function of x over 2, right? So here these two important functions, signum function and the greatest integer function, are involved, and let us first take the signum function, right? So let us take the definition of signum function. We know that the signum of some variable y, that is signum of y, is defined as +1 whenever y is greater than 0, right? And signum of y is equal to 0 whenever y is equal to 0, and signum of y is equal to -1 whenever y is less than 0, right? So this is the basic definition of signum function, and here from the definition we see that signum of y will take +1 value for all values of y which are greater than 0, right? And signum of y is always equal to 0 whenever y is equal to 0, right? And signum of y is equal to -1 whenever we have y less than 0, right? So here we have signum of x over 2. Now if we replace this y by x over 2, right? So we'll get signum of x over 2, right? So we'll apply this definition to y is equal to x over 2. So signum of x over 2 will take +1 value whenever y is greater than 0. So here we have y is equal to x over 2. So this is x over 2 greater than 0, right? Now this is an inequality, so we can write x over 2 greater than 0 as x is greater than 0, right? Okay, now signum of x over 2 will take the value 0 whenever y is 0, and here y is x over 2, so we have x over 2 is equal to 0, so x is equal to 0, because this is a linear equation, so x over 2 is equal to 0 implies x equal to 0, and signum of x over 2 is equal to -1 whenever y is less than 0, so y is x over 2, so x over 2 is less than 0, and this is again an inequality, so x over 2 less than 0 implies that x is less than 0, right? So now we have defined this function signum of x over 2 like this, so we can rewrite it as +1 0 -1, and here we have x greater than 0, here we have x is equal to 0, and here we have x less than 0, right? Okay, so once we have defined this signum function, let us take care of the limits of integration, right? So here we have the limits, that is here we have -1 and here we have 1, right? And between -1 and 1 we have 0, right? Okay, so now we see that when we take this interval, that is -1 to 0, that is this interval, then x is always less than 0, right? It means all the values of x which lies towards the left of 0 are less than 0, right? And if we take this interval, that is from 0 to 1, obviously x is greater than 0, right? So here see, we have x is equal to 0, this x equal to 0. So this is the point where we'll break this integral as a sum of two integrals. So now we can write this integral I as I1 plus I2, right? So I1 will go from minus 1 to 0, right? Because here the signum of x over 2 is involved, and we have just defined signum of x over 2 like this. So we'll use this definition to decide the value of signum of x over 2 in these two intervals, that is from minus 1 to 0 and from 0 to 1, right? So I1 is from minus 1 to 0, and we have e raised to greatest integer of x over 2, and here we have signum of x over 2 dx, and here I2 is from 0 to 1, right? So this is 0 to 1, e raised to greatest integer of x over 2, and here we have signum of x over 2, right? So 0 is the point where we have to break this integral I as a sum of two integrals, right? So this is a very important point while solving integrals of this kind, right? Okay. So now for this term, that is signum of x over 2, see, x lies between minus 1 and 0, and between minus 1 and 0 x is less than 0. So we have signum of x over 2 is equal to minus 1. So here we'll have for signum of x over 2 equal to minus 1, right? And here x varies from 0 to 1, right? And when we have x from 0 to 1, it means we have to consider positive values of x, that is x greater than 0. And when x is greater than 0, we have just defined signum of x over 2 as plus 1, right? So here we have signum of x over 2 as plus 1, right? So now these two integrals can be rewritten as minus 1 to 0 e raised to greatest integer of x over 2, and for this term we have that is signum of x over 2 is minus 1 dx, and here we have 0 to 1 e raised to greatest integer of x over 2, and here we have plus 1, right? Okay, so now we have seen that we have taken care of this signum function, and now let us switch over to this function, that is the greatest integer function, right? So see, in the first integral the value of x, it lies between minus 1 and 0, right? And in the second integral x varies from 0 to 1, right? But here we can easily see that we need x over 2, right? So what we will do, we'll divide this inequality throughout by 2. So we'll have minus half, and this is x over 2, and this is 0 over 2, that is 0, right? And similarly this is for the first integral, and this is for the second integral, right? In the second integral x varies from 0 to 1, right? But we need x over 2, right? So what we'll do, we'll again divide this inequality throughout by 2. So we'll get 0, because 0 over 2 is 0, and here we have x over 2, and here we have half, right? So now viewers, we need the value of greatest integer of x over 2, right? That is the value of greatest integer of x over 2, when x over 2 lies between minus half and 0. And similarly, here we need the value of greatest integer of x over 2 when x over 2 lies between 0 and half, right? So from the definition of greatest integer function, we can write the value of greatest integer of x over 2 when x over 2 lies between minus 1 and 0 is equal to minus 1, right? And when x over 2 lies between 0 and half, then the value of greatest integer of x over 2 is simply equal to 0, right? So these two expressions are written by virtue of the definition of greatest integer function. And always remember that the definition of functions are very important, right? Now here we can also verify these two results by taking a particular value of x over 2 in these two intervals, right? See here, x over 2 lies between minus half, that is minus 0.5, and here we have 0, right? So if we take any value of x over 2, that is, say for example minus 0.4, right? So minus 0.4, it lies between minus 0.5 and 0, and by definition of greatest integer function, the value of greatest integer of minus 0.4 is the greatest integer less than or equal to minus 0.4, right? So this is obviously minus 1, right? And similarly here we have x over 2 lying between 0 and half. So here we have 0 and 0.5, and if we take any value between 0 and 0.5, say for example 0.2, right? So by definition of greatest integer function, the value of greatest integer of 0.2 is obviously 0, right? Because the greatest integer less than or equal to 0.2 is 0, right? So now we have greatest integer of x over 2 is equal to minus 1, and greatest integer of x over 2 is equal to 0. So now for this term we can write minus 1, and for this term we can write 0, right? So now I is equal to minus 1 to 0, and we have e raised to minus 1, right? And here we have minus 1 dx, and here we have 0 to 1 and e raised to 0, right? And here we have plus 1 dx, right? So now we have two simple integrals to evaluate. So now we can simplify these two integrals. So we have I is equal to, see we have minus 1 over e, and we have minus 1 to 0, this is dx, and then we have 0 to 1, and we have here dx, right? Because e raised to 0 is equal to 1, and e raised to minus 1 is equal to 1 over e, and e is the famous exponential number, right? So now we have minus 1 over e. The integral of dx is x, limits are from minus 1 to 0, and here we have simply x, and limits are from 0 to 1, and this is minus 1 over e, and here we have or we have to substitute the limits, and we'll take the difference. So we have 0 minus 1, and here we have 1 minus 0, so this is minus 1 over e. This is minus minus plus, so we have 0 plus 1, and this is simply 1, and this is minus 1 over e plus 1, right? So this can also be written as e minus 1 over e, right? So viewers, the value of this integral is equal to e minus 1 over e, right? So this is how we solve this important and conceptual definite integral involving the greatest integer function and the signum function.